So, like most of these chapters, one kind of builds on the information from the previous one. And chapter 5 is going to take the skills that we learned in chapter 4, namely factoring, and apply it to rational expressions. So, rational expressions are some people's worst nightmare because they're not just math with letters in them, but they're fractions with numbers and letters in them. And so, we're going to take a look at just 3 sections of chapter 5. We are not doing the last section of chapter 5, so that's another part of the text that this course is omitting. In your work, you will see that the practice test says there is no test for chapter 5. In the material that I'm running with this semester, that's what it says. Back in the traditional format of this course, there was no test for it, but you will do your practice test like we've been doing for all of the other chapters, so same as all the others. So 5.1 is on simplifying rational expressions, and then we're going to get into the operations, multiplying and dividing, and then adding and subtracting. And we are really going to parallel stuff that we know from fractions. So rational expressions are fractions of algebra or algebraic fractions. So they're like fractions in every way as far as the operations go. So we'll need to remember that. But they do have variables and one or more terms. So all of these are examples of rational expressions. This is how they were different from other polynomials in that they have a variable down below in a lot of those. But technically, yeah, that's really the only difference here. So we're going to learn how to deal with these rational expressions. And the first thing we're going to deal with these rational expressions is simplifying them. When we had a fraction like 6 over 4 in math, we knew to simplify that. And that's what we're going to start with, simplifying these rational expressions that aren't just, number fractions, but fractions with algebra. So in this, excuse me, if we were going to simplify this fraction, I could think, well, I could divide the top by 2 and the bottom by 2, and we'd get to 3 over 2. Now, doing this just a little differently, I could think that I could factor a 2 out of 6 and be left with a 3, and I could factor a 2 out of 4 and be left with a 2. It's another way to get to the exact same answer, that you knew that 6 over 4 is 3 over 2. And what we're doing here is simplifying this fraction, and we're going to be doing this with rational expressions. So simplifying a rational expression is simply just putting the rational expression in lowest terms in reduced form. And there is this idea in the textbook that you could factor it and then cancel anything out that was the same. So anything that was a common factor, you could cancel it. Now, all of these, I'll give us a little bit of time in class, because ultimately, if you can get to the right answer with these ones, it doesn't matter how. This is technically the 4th time we've seen questions just like this, and it's the 4th different explanation of what the heck these ones are. And so in these, you can get to the right answer, and it might be worth just me throwing the answers up, and then I'll talk through how you get to the answers on these, because again, I'm going to try and parallel it into the information that's in chapter 5. But honestly, if you can get to these as your answers, you can use exponent laws, you can do anything you think. You can think of it as a monomial divided by a monomial, or you could go back to that first introduction to exponents to simplify these ones, or put them in lowest terms. So those are the 4 answers. You can give them a check. I will pause the video in class, and I will show all of my work for these ones. So talking through these ones, I'm going to do it in a particular way that allows me to reinforce the theories that are in this chapter 5. Again, if you got to the answers with your own strategy, totally fine, go with it. But do humor me in just listening through or contemplating the way that I'm about to show you with these. So A is just a fraction, and we know that we could reduce the top and the bottom. If we divided them both by 6, we could reduce it. We could also reduce it with fractions little by little, divide by 2, divide by 3. And so one way we could do it is to factor these numbers so that the common factor is out front. So we'd write 18 as 6 and 3, and we'd write 30 as 6 and 5. And now that I have it factored, I could see that the 6 divided by 6 could reduce, and I would get my answer of 3/5. Again, if you didn't do it that way, no worries at all. For C, or let's do B next. So for B, I could see that I could find a common factor to these two and write it out front. So I could pull a 2x out of both. And so factoring the top, I'd be left with it looking like that. And the bottom, I could write it and have it looking like that. And here, now I can cross those two things out to get to my final answer. If you thought about it as fractions and you thought about it with exponent laws, you are A-okay, good to go. This, what I've done in blue, is a different way of thinking about these. So talking these last couple through, so C, I could see that I could factor a 5x y squared out of both. So 5x y squared out of the top would leave me with a 3x, that's it. Oh, sorry, x squared. And on the bottom, if I have that same factor that I could break it apart with, I'd be left with a 4y squared down below. And so this then allows me to cross out the things that are the same and gives me another way to get to that answer that you probably already got to. So D, doing this in a similar way, taking a look top and bottom and deciding what they have in common, right? Going back to the language from chapter 4, thinking about these as common factors. I'd see that I have a 3a squared b common to both. And when I factor that out of the top, I'd be left with a 1. And on the bottom, if that 3a squared b is my common factor, factoring it out, I'd be left with a 3, an a, and a b. And again, this gives me a chance to illustrate getting to my answer another way. Again, doesn't matter how you get there, so long as you get there. There's a few more to try on the next page. I'm going to not show you every which way to do these. Again, let's just test that you know how to get there. So I'll throw the answers for these 3 up and take it from there. In class, it's kind of interesting to poll the group and see who's thinking of it which way. We have different brains and different people will have different kind of inclinations to think of them certain ways, but I really think it's important for me to be the spokesperson here saying, look, this is the 4th time we've learned how to do this stuff. So we just find one way that makes sense. Interesting to parallel between the different ways, but ultimately, functionally, you should be able to get there. Regardless of the wording in the given chapter. So F, I put a little star beside. There's a little bit of a note for that one. In this one, I wrote it with the negative down below. And so that might be the way that you wrote it. You can put that negative anywhere. So the negative could go anywhere. We've been doing lots of fraction work, and the first time I was introduced you to this, I said -1/2 could be -1/2, or it could be 1/2, right? Those are all equivalents here. So with this one, however you want to think about it, you'd end up with a negative somewhere. So if you put it down with the y, I did it like that because it's the most common way that students tend to give this answer, and I didn't want to throw anybody off, but you could put the negative out in front of your answer, and it means exactly the same thing. So don't get thrown off by the negative signs. So those would be monomials times, or monomials in as rational expressions. We're going to move on to, well, what if it's more than monomials that are making up these rational expressions? And so our name of the game here, there are 2 pieces of information, 2 steps to simplifying these. These are also the steps that I was modeling for the first part. So I'm going to factor things and I'm going to cancel out anything that's exactly the same top and bottom. And that's why I showed you my way of doing it, or the chapter 5 way of doing it in those first ones that you might think of in other ways. So again, to parallel from this chapter 5 stuff. So what we're supposed to do with A here is factor the top and factor the bottom. And then take a look to see if there's anything exactly the same top and bottom, because something divided by itself is 1 and it wipes itself out. So the top part of this rational expression, when I take a look at that binomial, I can see that there is a 2 common to both. Always check for greatest common factor first. And factoring that out, I'd be left with an x minus 2 on the top. I'm done factoring the top, so now I'm going to factor the bottom. When I look at the bottom, there is no greatest common factor to those two terms, but there are two terms there, and I could recognize it as a difference of squares. So following my pattern for the difference of squares, I would have the bottom part of my rational expression all canceled. Now comes the fun part. Anything that is exactly the same top and bottom, I can cross right out in order to simplify this rational expression. So my rational expression in lowest terms, or fully simplified, would be 2 over x plus 2. Now, you can put the brackets around that x plus 2 in your answer, or you can leave them out. When we went about this right from the beginning, I said this was a grouping sign. And so it implies that there are brackets around there. So that's optional. Brackets or no brackets, it's the same. It's right either way. And so you can choose what you like to do. I tend to leave them out, but it's not wrong if they're in. So trying this strategy out here where we're supposed to factor and reduce. For b, I can see on the top part of my rational expression, I have two terms and I have a common 3 factor to both. And factoring that out, I'd be left with an x squared minus 1. On the bottom, I would take a look at this, and it's a trinomial. And this trinomial, if anybody's senses are tingling, I'm going to come back to that one. So I haven't forgot it, haven't made another mistake in the video. When I take a look at the bottom part here, I have a trinomial. There's no greatest common factor, so I'm going to get pushed into the AC test. The top of my number puzzle would be a 1 times -3, so -3, and I'd have to factor 3 as many ways as I can, so that's just a 1 and a 3. They're supposed to multiply to give me a -3, but add to give me a -2, so I get this mismatched thing where the larger factor is going to be positive, the smaller is going to be negative. I'm going to use the shortcut because of the 1 in front of the x squared. And again, knowing when you can use that shortcut is important. So if you're not comfortable using the shortcut, there's lots of space on the page. You can use the long cut. But this polynomial that's down below, my denominator and my rational expression, factored would give me an x plus 1 and an x minus 3. So we're back to this case of why did I put a star here? You always have to check that things are fully factored. And so on the top, that is not fully factored. I have a really sneaky difference of squares there. And so factoring this, because 1 is a perfect square, I would be able to write it out as x plus 1 and x minus 1. The bottom, I'm just going to copy again. So now I have everything fully factored. That's step 1 of the plan here, is to factor, and then I get to cancel out anything that is exactly the same. They might be in brackets, or it might just be things that are the same. And so I'd cross out that x plus 1 and write my final answer as 3 x minus 1 all over x minus 3. That is my polynomial, or my rational expression, in simplified form, in reduced, in lowest terms, if you think about fractions. There's a number more to do here. Again, 2 things. You're going to factor and you're going to reduce. That's all we're doing. And I find that pretty shocking that a whole chapter has 2 words as all the instructions on how to do it. They're big words because factoring is a huge amount of things to do. So taking a look at C, I would factor the top. There's no greatest common factor. I do have this pesky 2 here. Which means there's no shortcut. So for this one, I'm going to show my rough work. I'm going to show factoring the top. I'm going to show factoring the bottom because it's just too much to do in place. And so the top would have 2x squared plus x minus 6. So at my number puzzle, I'd have a -12 at the top because remember it's 2 times -6. I'd want to factor it in as many ways as I can. And I've got my signs to consider. So I'd have a +4 and a -3. Those are the numbers that are going to decompose my middle term. So I'd have 2x squared minus 3x plus 4x minus 6. Now that I have it with 4 terms, I can factor by grouping. Factoring an x out of the first 2 terms would leave me with a 2x minus 3. And taking a look at the second 2 terms, I could see that I have a plus 2 common to those. And factoring that out, I'd be left with a 2x minus 3. Finishing this one up, I have that 2x minus 3 as my common factor, and factoring that out, my second binomial here would be an x plus 2. So that is the top in factored form. So I'm going to rewrite that 2x minus 3 and x plus 2. That's the top factor. Now I'm going to do the same thing for the bottom. So the bottom is this 2x squared minus x minus 3. So my number puzzle for that, I'm going to do kind of over here, out of the way, would be a negative 6 at the top. And factoring 6 as many ways as I can, I'd have 1 and 6 and 2 and 3. I have that pesky case of having a negative 6, so that mismatch in the sign of my factors. I have a b term of negative 1. So positive 2 and negative 3 are going to be what satisfies my number puzzle and helps me decompose that middle term. So I'd have the 2x squared out the front plus 2x minus 3x, preserving the value of this polynomial, and minus 3. I have it expanded to the 4 terms, so I can factor by grouping. Common factoring the first 2 terms, I'd pull a 2x out of those and be left with an x plus 1. And common factoring the second 2 terms, I'd see a negative 3 common to those 2. And factoring that out, I'd be left with an x plus 1. So the bottom, last step in factoring this, I would have an x plus 1 and a 2x minus 3. So that is now the bottom fully factored. So I can rewrite this as x plus 1 and 2x minus 3. So now that I have it fully factored, if you can see it in between all of that, I have these big ugly brackets all the same. So my final answer here would be x plus 2 over x plus 1. That is my polynomial that's fully factored. F gives me another one to take a look at. I'm going to factor this one. Mercifully, that one is like the worst question on this entire page in this entire section. F, I would take a look at greatest common factor first on the top. And so I would see that I have a 2x common to those 2 terms. And factoring that out, I'd be left with a 3x plus 1. And on the bottom, taking a look at those 2 terms, greatest common factor would be a 2x, and factoring it out would give me an x plus 6. Here I have not the brackets matching, but that 2x matching, so I could cancel that out because it's something divided by itself being 1, and my final answer would be 3x plus 1 all over x plus 6. I'm going to keep talking these ones through. You might be catching the hang of these, especially after we got past C and how much work that one takes. The ones at the bottom here, for D, common factoring a 5 out, I'd be left with an x minus 3. And the bottom part here, no greatest common factor, but it is a difference of squares. So I'd have x plus 3 and x minus 3. Everything in this one's fully factored, and I get to do this really fun step of crossing those things out. So my final answer would be 5 over x plus 3. And again, you could put brackets around that x plus 3, but you don't have to. Maybe I'll just throw the answers up for G, E, and H. You might be catching the hang of this one. So I'll throw the answers on the video here. In class, you can work ahead on these ones. And then the video, I will talk my way through them, showing all my steps along the way. So showing my work in this for G, when I take a look at the top part of my rational expression, I don't see any common factor, but I do see a difference of squares. So I'd factor the top with difference of squares pattern. The bottom, I see a trinomial, so that would push me into the AC test. There is no greatest common factor. I can see that it's a simple trinomial, so mercifully I can use the shortcut, which I'm all about when I can. I'd have 1 times 8 at the top of my number puzzle, so a positive 8 factoring 8 as many ways as I can, and it's a positive 8, so they're all positive or all negative. I've got a positive 6 as my B term, so plus 2 and plus 4 satisfy my number puzzle. And the whole deal with the shortcut is that if there is a 1 out the front here, the numbers from my number puzzle are the numbers in my binomial factors. If you're still not ready to take that leap, then go ahead and use the long cut, but my work's going to seem a little bit quick for you probably. If I cross those two out that are exactly the same, that's how I get to my final answer. For E and H, rounding this one out and rounding out this video, because that's usually enough to manage. E, the top of this rational expression, I have a trinomial with a plus 6 at the top of my number puzzle. It's a simple trinomial, so yeah, shortcut. I've got 1 and 6 and 2 and 3. I want them to multiply to give me a positive 6, but add to give me a negative 5. So that means that all of my factors are going to be negative. That means that negative 2 and negative 3 are going to be the numbers in my binomials in factored form. The bottom part of this rational expression, I could common factor a 3a out. And when I do, I'm like, whoops, I just changed from a's to x's. Sorry about that. I don't know why. I guess I get used to dealing with x's and I switch it. So that's a minus 2 and a minus 3. Somebody's probably screaming at the video here. Okay, so then common factoring a 3a out, I'd be left with an a minus 2. So now that I have the things that are exactly the same, I can cross them out, and that's how I get to my answer. Last one on the page, last one in this video. Taking a look at these ones as far as common factors go, the top part of this rational expression, there is a 3x squared common to both. And when I factor that out, I'd be left with an x and a minus 2. On the bottom, when I take a look at that, I can see that I have a 3x squared common to that, and I'd be left with then a 3x squared and a minus 1. Crossing what is exactly the same out, top and bottom, it's usually the brackets, but sometimes it's not. That's how I get to my final answer. That's the end of this video. There's one more little topic in the 5.1, but that's usually enough for the first little bit of this.